Hello and welcome, everyone. My name is Pavel Sul. I'm the Chief Technology Officer here at MIPAR Software, and today I'll be presenting a webinar on MIPAR version 4.3.0 update, specifically highlighting custom measurements. To give you a little bit of background on MIPAR, the software was invented at The Ohio State University in the Material Science Department. It was developed by active users who were trying to solve real-world problems when it comes to microstructure analysis. We've been around since 2017. It's almost hard to believe that we've been doing this for 6 years now. Since then, we have worked with hundreds of companies and universities to help them improve their workflows in computer vision, image analysis, microstructure analysis, et cetera, across many fields, including material science, biomedical research, agriculture, and so on. We have a worldwide user base and distribution network. So those of you that are outside of North America, chances are that there is a local distributor that is able to help you with MIPAR. What we'll be discussing today, the first thing we want to cover is what are custom measurements, how do they fit into the rest of MIPAR, how does that layer interact with the rest of the software. The next thing we'll talk about are industry applications, demonstrating custom measurements, specifically defect analysis in additive manufacturing, demonstrating pass-fail analysis. The second application that we will discuss is ASTM metal grain size analysis, where we want to demonstrate how to dynamically set up custom measurements to detect grain anomalies. These would be as large as grains, also referred to as ALA. For those of you that are interested in building these measurements and managing them for your team, you can stick around, and we'll have a second portion of this webinar will be for those power users, as I refer them to, where we'll discuss management of custom measurements and measurement building. So in general, MIPAR operates on most solutions that we provide operate on three basic principles: detect, measure, and report. MIPAR's detection engine combines deep learning technologies and artificial intelligence technologies with conventional image processing that most of you may already be familiar with. We find that this gives us a really good balance between the power that deep learning brings and some of the rule-based systems that conventional image processing allows us to put together flexible yet robust systems that we are pretty proud of here at MIPAR. MIPAR measurements are accuracy focused, meaning we will never sacrifice accuracy for performance. Our goal is to deliver the most accurate possible measurement that we can once what we found is detected, or the thing that we're interested in is detected. And lastly, seamless reporting. We want to make sure that anything that comes out of MIPAR, it's pretty streamlined. So these reports are output to Word documents, Excel documents, text files, TIFF images, and none of this is proprietary. So you're able to take data out of MIPAR and process it downstream without any problems or having to worry about some proprietary file type or things like that. The way custom measurements fits into this is we wanted to expand on our measurement engine, specifically allowing us to customize our measurements for industry specifications. These are requests that we've received from a customer base over the years, and I'll talk about that a little bit more as we move on here, obviously. But many of the features and this initiative really came from our customer base. So like I said, custom measurements, our goal was really to allow our users and our MIPAR operators to do more with MIPAR in MIPAR. What does this mean? Well, if we are trying to reduce the amount of data post-processing outside of MIPAR, this results in, basically boils down to fewer spreadsheets, fewer things that have to be maintained and processed after the fact. And I think all of us can use fewer spreadsheets. The other thing is every time we eliminate this transition point between our software and data post-processing, this reduces the amount of standard operating procedures and less documentation to make, less documentation to maintain is always great. And lastly, because custom measurements allow us to configure our measurements to specific industries and problems, because we work under such a wide range of applications, we're able to configure our measurements to use industry-specific terminology and configure in a way that is closer to what our customers expect in terms of reporting. And this improves operator experience. And we know that when it comes to having to train a new technician or things of that sort, using terminology that they're already familiar with is always really helpful. Okay, so how do we do this? To introduce a high-level version of what custom measurements in this layer is. Again, we'll talk about building these and managing these later on in the webinar, but this is just a quick introduction. So first example is measurement renaming. Let's say that MIPAR is using caliper diameter as a way to define our longest distance across a feature, but your team refers to that as a critical distance. With custom measurements, we're able to do that, and now when you have new operators joining the team, they're able to see that terminology in MIPAR. The second one is measurement mapping. This allows us to set up, we'll call it binning or mapping, these things that say that, look, if let's say our area fraction is greater than 0.4567, this means that that measurement or that sample failed, I should say. Well, if that's the case, we're able to remove this processing and decision making from outside of MIPAR. This can now happen entirely in the software, and then the report can almost immediately reflect that. The other request that we received is defining new measurements. And this is really where the first level of the power when it comes to custom measurements is being able to define your own configured measurements. In this case, the example I'm using is, let's say you want to define an average diameter as the mean of our caliper diameter and the minimum diameter. You can now do that. And then once you've defined this measurement, it can be used in the rest of the software. You can put together reports with it, export that measurement. It works exactly like everything else would. And lastly, we've introduced logic operators to basically say, let's say you want to define the measurement in one way when, let's say, area fraction is greater than 0.890, and a different way when it's not. So, excuse me. And this is really where the power of custom measurements starts to really increase, because these logic statements can really allow you to expand on how much can be done with MIPAR. And this is the type of statements that we had used to generate the ASTM grain size measurement, which I'll be demonstrating here shortly. Okay, so why do we why do we pursue this next level of automation? Well, boil down, improved automation leaves less room for mistakes, and with fewer mistakes, we improve the efficiency and effectiveness of anybody who's using MIPAR. And at the end of the day, because of a lot of analysis that happens in MIPAR tends to be routine work. The less time you spend doing routine work, the more time you have to do creative problem solving, which is what I think most of us would love to do more of. So that's kind of the goal and the vision for custom measurements and MIPAR in general. Okay, so the first application that I want to discuss is additive manufacturing defect analysis. I do not want to spend much more time in slides. I'm just going to jump into MIPAR here. I think that's the best way to learn and demonstrate anything. Fewer slideshows and more actual software is always great. So those of you that are new to MIPAR, this is the image analysis or image processor interface where we build, process, optimize images really one at a time in this interface. The batch processor is used for batching images or applying an image analysis algorithm to a set of images. We'll discuss that again later on in the webinar. But let me go ahead and pop open one of these images. So those of you that have been MIPAR users for a while, you may find this image familiar. This is an additive manufacturing cracks and pores image that I think we've used for previous demonstrations. Basically, the goal here is to detect the cracks and the pores separately and quantify their area fraction. So let's go ahead and load our recipe here. Again, that was pretty straightforward. Let me close this out. I can select my recipes from up here, the ones I'm using on a regular basis. I can also drag and drop them into the interface, whichever way you prefer to work. Okay, so let's take a look at our detection here. So if we just take a look at the image, again, the goal is to detect cracks and pores. We have a layer defined as sample. This is the total defects in the image. And then we separately subclassify these into cracks, which are these round features, and cracks, which tend to be these long and branched features. So the goal is to really define the area fraction within MIPAR. And that's pretty straightforward. I mean, that's a simple area fraction measurement relative to the rest of the image, no problem. Well, a lot of times what we would get a request for is, well, how do I want to be able to say whether or not this sample passed or failed based on this measurement. So with custom measurements, we're able to introduce a status measurement that says, okay, in this case, if my area fraction is less than 10%, the whole sample passes. And then subclassifications to say, well, if the pores are less than 5%, the sample passes, but if the cracks are greater than 5%, the sample fails. This allows us to be more granular with the classification of this morphology. And then it's up to the person who's processing the sample to make the final call. But if we take a look at this report, we can see how we can seamlessly defect analysis, take what we have here and then export this into a Word document. So I just click print report right there. It gives me this dialog where I fill out the header information for this report, which is up here. And then MIPAR exports everything that you saw in the image processor into a Word document. We have everything, all the measurements that we care about. The operator is able to add comments to this micrograph analysis, sign off on it, and send it out. Again, pretty straightforward. No need to process this information further, add new columns. That was all done with MIPAR with a single workflow. So the other thing I would like to demonstrate is when it comes to routine analysis, we can see how QC labs are able to take in the sample, prep it, image it, analyze it, and it's just part of their workflow. Well, a lot of times what happens is R&D teams are also doing additional analysis of these samples. And for example, let's say that the QC team is doing their analysis on area fraction, but the R&D team also wants to know about, let's say, the number density of the pores, so number density relative to the entire image, and the path length of the cracks. Path lengths is exactly what it sounds like. It's how long these cracks are along the path of the crack. And let's go ahead and redefine our measurements here to make sure that we're not generating number density on the pores and only the path length on the cracks. And let's go ahead and regenerate our report. So just like that, a report that was fairly routine now includes 2 additional measurements that then can be passed along to the other team to do additional analysis on. So this is just an extra data point that they can use for modeling this material and its microstructure. Same deal where you type in print report, everything that you saw in this table then gets output into our Word document. So our report here got expanded. So we have our number density of the pores and the path length of the cracks. So the other thing that I want to highlight really quick is that, if you don't like the Word document format, you can copy this into a separate Excel document and then save these images into that Excel document as well, if you prefer to do that. So that was a quick overview of this pass-fail analysis example from additive manufacturing. The next example that I want to talk about is the ASTM grain size analysis. And let me pull up an image, that way we can look at the same thing here instead of just looking at a slide. Okay, so this image was borrowed from the ASTM standard for ALA detection and classification, ALA meaning as large as, when it comes to grain size. I don't want to get too much in the technical details of this standard. That can get pretty tedious and boring. I just want to use this an example of how to highlight custom measurements. But basically, the idea is when a feature is present in an image that is much larger than the rest of the population, we want to highlight this feature and then measure it in a different way. For those of you that are not familiar with material science, really these large grains can have an impact on the material properties. As you can imagine, with the rest of the structure is fairly small, homogeneous. Having something like this as large as this can almost act as a defect in the structure. So the standards highlights cases where when it's present, it needs to be highlighted and included as part of the report. So with that, let's go ahead and load our recipe here, and then we'll talk through it. Okay, let's talk about our detection first. Let's change this to outline and 1. I think it's easier to see. Right, so we have our grains outlined here. I think that's pretty well set up. And let's talk through our report. Right, so our grains have been detected. Our grain size number G, this was calculated using the mean area of the grain structure. Then we have a grain anomaly status. This tells us whether or not a grain anomaly was detected. In this case, it was. And then grain size anomaly size G. So this tells us a grain size as defined by that ALA standard of that grain. And the reason we like to highlight this is, like I said, it needs to be included in these material science reports because change this size. It tends to be a requirement when processing this material. Same deal with the report generator. This outputs exactly how we're expecting it to: grain size number, status, and then anomaly size. Let's go ahead and open up an image that, actually this one also has an anomaly. Let me grab my other image here. So yeah, same deal. Rest of the structure has a grain size number of 9.8. This one has a size of 3.3. If I grab my grain size image, that is much more homogeneous, we'll see that in this case, because the grain size anomaly status is not detected, this outputs the grain size number similar to what the other one is, or identical. Was just a way to highlight that. The other thing I want to demonstrate with custom measurements is this is entirely batchable and works with the rest of the software. So let's go ahead and do that. So we have loaded our recipe. We're going to drag and drop our images that we want to process into MIPAR, and let's just go ahead and click process. Once this is done, MIPAR outputs a measurement CSV per image that highlights the measurements that the recipe included, including the status, and this can be shared and or processed downstream if you need to. This is a CSV, or it can be open in Excel, very user-friendly. The other thing you can do is you can review the session. So let's go ahead and do that. This allows us to review the detection results. So to make sure everything is working as expected, you can also regenerate our custom measurements from this interface. So let's go ahead and add that. Status anomaly, add, generate. It gives me a similar table as I always saw in the Excel document. I can then, let's say, double click on this. MIPAR will pull up the exact image that you care about. Let's say that in this case, the anomaly not detected. That's what I care about. It will pull up this image for me. I can even go back to the image processor. I want to reopen this image, reload. MIPAR will open the image from the post processor back in the image processor. That way you can take a look at it in this interface as well if you want to output an individual report of that. Again, everything is pretty seamless when it comes to setting up these workflows. Same deal when it comes to this. If I want to print a report out of here, green size, right into something here. Should be able to just save this, right? So yeah, you can output things from this interface into similar reports that we saw before. And same deal when it comes to this grain size, as the defect analysis. In those cases when the QC team is doing the grain size detection, but the R&D team is looking to further quantify these grains and let's say their shape, in addition to in addition to just the grain size, let's say we care about the eccentricity, we can add this, and then we can open up our color by measure report, and this tells us how basically round our grains are, which can be another data point to process downstream. So just like before, if you want to regenerate this measurement, now you have the mean eccentricity here in our general report. Okay, so that was our grain size analysis demonstration. If you are interested in learning how that was built and the workflow for that, you can stick around. Those of you who use MIPAR but are not so much involved in recipe building, any workflows after this or anything demonstrated will be specific to custom measurements and their management and building. Before anybody else wraps it up here, if you are an active customer and you are interested in custom measurements, talk to your application specialist. You can email us at support@mipar.us. This is the best way to communicate and reach us. We'll schedule a session and talk about how we can either convert your existing recipe to use custom measurements, to use some of this awesome stuff like use industry-specific terminology, create new formulas to help simplify data post-processing. Yeah, we can schedule a time to talk about that on a per application basis. Those of you that are new customers or who are interested in MIPAR, please schedule a demo with our sales team at sales@mipar.us. We're able to configure our recipes to your data. Again, flexible detection, now flexible measurements and seamless reporting. That can be used to configure MIPAR to your application. Yeah, so the next portion of this webinar is I want to review custom measurement building and management. My purple slides here are for my power users. Basically, a custom measurement consists of three main components: a measurement name, a measurement formula, and a measurement mapping or bidding, depending how you want to refer to it. Measurement name is pretty self-explanatory. You're just assigning a name. Measurement formula is a little bit more involved. This is where you define how that measurement should be calculated. You can use basic arithmetic if you're just trying to define a constant. You can use other built-in measurements. So for example, if you want to use the area of that layer as part of defining your new measurement, you can use that as a variable. So the example here I have is that the area is being adjusted by a factor of 0.987. That's pretty straightforward. And then really the powerful aspect occurs here when custom measurements are able to be used as a definition of other custom measurements. What this allows you to do is to have this nested logic and these definitions that can get fairly complex, but also fairly powerful. So that's really the big benefit of custom measurements. That's really where the power happens. The next component is measurement mapping. I touched on this earlier, where we want to bin the data that's being output from the formula into subcategories. A Boolean example. So let's say if our area fraction is within one range, we want to output true. If it's outside of that range, we output false. If it's numeric, so let's say you want to bin your data like a histogram binning almost to output other values. when your formula outputs to a specific range. That's achievable using numeric mapping. And then lastly, text mapping, which was demonstrated in the pass-fail analysis, where we said that if the area fraction of the total sample is less than, or the defect of the total sample is less than 10%, we output the text pass, otherwise it fails. So this allows us to convert numeric values to a text output, which is fairly helpful when simplifying these reports for operators. Okay, like I said before, I don't want to spend too much time on slides, so let's jump back into MIPAR here and actually work in the interface. So let's pull up our pass-fail example and dig in to see exactly how it was done. Right. So let's change this back to overlay. Cool. Yep, those of you that are familiar with this example, just demonstrated it outputting pass for area fraction less than 10%. So let's go ahead and take a look how that was built. So we want to edit our measurement here. Yep. And let's take a look at the status here. So measurement name is my status variable. It's a custom variable. And let's go ahead and edit this measurement to see exactly what its components are. Right. So this can be a little bit intimidating at first. There's just a lot of fields and some stuff, but it's fairly straightforward. Let's talk through this. So a measurement name is exactly that. You define the name for the measurement, and this is how MIPAR will refer to that measurement in dialogues and reporting. If you include more than one measurement with the same name in these reports, MIPAR will override it. So you just have to be careful. You can build multiple measurements that share the same name. You cannot include them in the reports because MIPAR will just take the most recent one. You have to define a variable name, and this does have to be unique. This has to be unique across all custom measurements in the software. So, and it also cannot share a name with built-in measurements. And I'll talk a little bit more about that here in a moment. So you just have to be careful when defining it. We recommend using good practice when it comes to defining variables, because it's exactly what this is. So it needs to be descriptive and unique. And then this is our formula. In this case, we're taking the image area fraction, which is area fraction of our layer, and then we define entire as what's relative to. You can also define this relative to companion images, memory images, all the other functionality that you may already be familiar with when it comes to recipe building. Custom measurements actually has expanded capabilities on that, meaning you can define the area fraction relative to memory image, whereas the software only allows you to define it relative to companion or the entire image. So that's an additional benefit of custom measurements there. A description, same deal. Just a good description is a great way to keep track of what you're building and exactly what this is doing. You don't want to have to go back and parse through the formula to figure out what it was doing. Just write a good description and maintain it to make sure that you know exactly what the formula is doing and what the goal of it is. It's not required, but we highly recommend it. A status dialog here that just tells you if you made an error in any part of this. MIPAR will tell you a detailed description of, let's say if you made a mistake and you named a variable name of another custom measurement, MIPAR will notify you of that. Okay, so mapping. This is really where this measurement happens. So we define this range where we want the value to be output as pass, otherwise it fails. So For example, in this case, if our range is from -infinity to 10, we output the text pass, otherwise it fails. So that's really straightforward. But we just have to remember that this mapping acts on this formula. So whatever this formula outputs, that's what's being mapped to these new values. So that was a pretty straightforward example of how to put together a mapped measurement here. MIPAR will highlight these as green when you share them between the added recipe or the available measurements. In cases where, let's say, a MIPAR engineer shares a recipe with you, you can import that measurement that was part of the recipe into your own recipe bank and use it later on as well, which is pretty useful. Measurements can be saved and loaded from files as well if you want to share them that way. So the one thing I have to say when it comes to this measurement manager here, you may notice that it says custom image measurement manager, image being the key word here. So these custom measurements are specific to the image measurements. So exactly how we are referred to them here, where we're measuring image, but usually what that means is we're outputting a single measurement per image. Whereas in contrast, a feature measurement will output a measurement per feature. So there's a clear distinction there, meaning you cannot output a custom feature measurement as an image measurement. And for that reason, custom image measurements have their own management window here, and I'll talk about the custom feature measurements here in a moment. When it comes to managing these, again, use good practice, just like with anything else, when it comes to good descriptions and good variable names, because you will be using that in the future. For example, when we jump into the area fraction here, I overlooked highlighting this. If you click on variable operators, this is the formula help window here. What this does is it gives you a full table of all available operators and their syntax and how it needs to be used if you want to use it as part of the formula. It gives you the name of all available built-in measurements. This is a pretty extensive list. MIPAR has quite a few measurements that it outputs. So we make all of these available to you to use as part of your custom measurements. And lastly, variables that can be used as custom measurements that are defined as other custom measurements. So again, these have to be unique, but all of this is listed here. You can copy and paste out of this. So if you want to select a cell and you don't have to worry about exact text, you can select this cell and hit Control-C and then Control-V into your formula. That way you don't have a problem with misspelling something. The other thing you may notice is that, for example, there's two areas here. The description tells you that, or the variable name also tells you that this is a feature area versus image area. So this is the area of the layer versus this is the area of every single feature in that layer. So even though these can be used as part of the formula in the image measurement, like I said, they have to calculate down to a single value when it is an image measurement. So for example, if I want to use feature area as part of my custom image measurement, that feature area, let's say I want to take the mean of that feature area, that calculates down to a single value, allowing us to use it. That's why this is available to us. These variables are available to us during a custom image measurement building. Okay, speaking of custom feature measurements, let's go ahead and take a look at that. So just like custom image measurements live in our custom measurements here, custom feature measurements live in the feature measurement window. So those of you that are familiar with MIPAR are familiar with this interface. This is the list of all the feature measurements that the MIPAR has to offer. Now there's a new button that says Add Custom. This opens a window that looks very similar to the custom image window. That's intentional. But the only custom measurements that are listed here are custom feature measurements. These are measurements that are output per feature. It can be used like feature measurements, just like anything else. So let's go ahead and let me load up my grain image here. I think that's going to be a better demonstration of this part of the webinar. Okay, so measure features, grains, add custom. So in this example, if you remember, we define the ALA grain size using a formula here. So if we go to use our ALA map, and let me edit this to show you exactly how this is built. So the standard gives us a formula to convert the feature area into an ALA size. We simply type that formula into MIPAR, and now what I get is a grain size number per feature. So when I can now add this to my recipe, I can add this to my like I said, add this to my recipe, and I can run this just like any other feature measurement. So I get a grain size number per feature. I can sort this if I want to, just like you could before. I can click on the largest cell, click on any cell that I care about, and it will highlight that in the table for me. It allows us to investigate this grain size a little bit further if we want to. We get a distribution here with a clear anomaly where we have a grain size of 3, well below the rest of the curve. So that's basically feature measurements, custom feature measurements, as I should say. They act exactly like a feature measurement would, except allows you to define that using your own formula. So yeah, that's basically a quick overview of custom measurements, how to build them, and a quick introduction on how to start to managing these. So this is really version 1 of custom measurements. We are listening to our user base, to our application specialists, and continue to expand the tools available inside of custom measurements, improving that experience. So if you have input as to how you're using it and how would you like that workflow to adjust to better meet your needs, look, we're a customer-driven team here. So if you have suggestions of how to improve custom measurements, we're very happy to work with you. So if you would like to schedule a one-on-one training on custom measurements with an application specialist, again, reach out to your support team. That's support@mipar.us. An application specialist will reach out to schedule a good time for both of us. New customers, if you would like to schedule a demo to see how this can be used for your applications, again, we configure our solutions to your data so you can see exactly how this would work on your imaging data. Please reach out to sales@mipar.us. Some things that are coming up that we're actively working on. These are going to be future updates of MIPAR Live microscope control. We continue to expand the camera support for MIPAR Live and continue to expand our batching capabilities through MIPAR Live and integration with microscopes. That's pretty exciting to us, and yeah, again, the fewer interfaces that we have when it comes to working with image analysis, the better off the operator is, the whole workflow, and we can introduce more automation to the microscope control. So we have some exciting stuff happening when it comes to our MIPAR Live product. Deep Learning v2 is in the works. We're working on upgrading our engine architecture, and then expanding artificial intelligence into other MIPAR systems. We have some more details on that coming soon. Pretty excited about that. And then version 2 of the report generator, where we would like to be able to batch report through the batch processor. I think we've had quite a few requests when it comes to that. So we are working on expanding the batch processor capability to generate those reports. Additional report customization, even though we can already customize our report templates to some extent, we are continuing to improve the customization of those reports to make sure it, again, meets industry requirements. And lastly, new formats. Some of you have requested Excel output reports where the images are included in the Excel report. We're taking steps in making sure that's possible in future releases. So I want to say thank you for attending today's webinar. Our goal here in MIPAR is to continue to build out automation in image analysis and these workflows. And we are excited to see the problems that you're solving with custom measurements, and seeing if we can help with continue to build out these capabilities. You will receive a link for a replay of this webinar. If you want to share it with a colleague, feel free to. And if you have any questions, again, reach out to support or sales@mipar.us. We will have some follow-up emails regarding the webinar in case you are looking for additional materials and things like that. All right. Awesome. Thank you for your time, and we hope to hear from you soon.